For a long time, building an AI model required something very specific. Not just data, but code. And not just code, but deep familiarity with frameworks, tuning parameters, and trial and error workflows. But recently, something subtle has changed. Today, people with no background in machine learning are training models that actually work. Not because the math disappeared, but because the system around it changed. This video is about AutoML, not as a product category, but as a shift in how machine learning is built. What AutoML actually is. AutoML stands for Automated Machine Learning, but that phrase can be misleading. AutoML doesn't mean machines are doing AI by themselves. It means the most repetitive, fragile, and error-prone parts of model building are now handled by systems instead of humans. Traditionally, training a model involved several steps: choosing an algorithm, preparing and cleaning data, selecting features, tuning hyperparameters, evaluating performance, and repeating everything many times. AutoML turns this workflow into a guided pipeline. You provide a dataset and a goal like prediction, classification, or forecasting. The system handles model selection, feature experimentation, tuning parameters, and performance comparison. What used to be weeks of iteration becomes hours or minutes, not because the work vanished, but because it became systematized. What's actually changing under the hood? This isn't magic, and it's not new math. What's new is how these steps are orchestrated. AutoML does three quiet but important things. First, they search. Instead of a human guessing which model might work best, the system tests many options in parallel. Second, they measure consistently. Every candidate model is evaluated under the same conditions, reducing human bias and inconsistency. Third, they learn from the process itself. Some systems remember which approaches tend to work for certain data shapes and problems. This turns machine learning from a craft into something closer to an engineering pipeline. And that distinction matters. A simple example without code. Let's walk through a practical scenario. Imagine you have a spreadsheet, customer data, purchase history, support interactions, and you want to predict which customers are likely to cancel their subscription. With AutoML, the workflow looks like this. You upload the dataset. You select the target column, canceled or not canceled. You click Train. Behind the scenes, the system tests multiple model families, experiments with feature combinations, tunes parameters, and compares results. What you see is not code, but feedback. Accuracy scores, confidence intervals, feature importance. You're not told how the model works line by line. You're shown how well it behaves. That's the shift. Why this lowers the barrier, but not the responsibility. AutoML makes model creation easier, but it doesn't remove accountability. You still decide what data goes in, what outcome matters, and what errors are acceptable. If your data is biased, the model will be too. If your goal is poorly defined, results will be misleading. AutoML removes mechanical difficulty, not judgment. And as the tools get easier, the quality of decisions matters more. Where AutoML is already being used. AutoML isn't experimental anymore. It's quietly embedded in business analytics platforms, marketing optimization tools, fraud detection systems, forecasting dashboards, and no-code platforms. In many cases, users don't even realize they're using machine learning. They think they're building a forecast, scoring leads, or flagging anomalies. But underneath, AutoML is running continuous experiments. The intelligence isn't in a chatbot. It's in the process. What this means for creators and builders. For creators, AutoML changes the starting point. You no longer ask, "Can I build this?" You ask, "Is the data good enough? Is this the right question? What happens if the model is wrong?" The bottleneck shifts from technical skill to conceptual clarity. The trade-offs. AutoML isn't a perfect solution. You gain speed, but lose some transparency. You gain accessibility,
but reduce fine-grained control. That's why oversight becomes more important, not less. A subtle behavioral change. Older AI tools waited for instructions. AutoML systems are continuously evaluating themselves. Is this model still performing well? Has the data changed? Should something be retrained? This is a move from static intelligence to adaptive infrastructure. A calm conclusion. AutoML doesn't make machine learning trivial. It makes it reachable. The complexity is still there, just organized differently. And the most important skill isn't coding. It's knowing what to ask and how to interpret what comes back. That's the quiet shift AutoML represents. Not automation replacing thinking, but systems making thinking easier to test.